Welcome to TopSolid 7. In this video, I'm going to briefly introduce you to programming a mill turn part on an Integrex 100 SY. This is the machine in question. This is the part. Now, here I'm going to skip a few steps, and those steps are the loading of the part, the choosing of the machine, even setting up some of my tooling. But I will also tell you that I'm also working on a video tutorial that will cover every aspect of programming this part. This video is just a bit of a tease, in fact, just to let you know what's coming. So let's get started. To begin with, I'm going to go ahead and simplify a little bit of what I'm looking at. I'm going to go to my machine display here and turn off the ground elements. The ground elements are typically the non-moving elements. This way it's a little bit easier to see what we're doing. Next, I'm going to zoom way up on my part here, right-click on that front face, and we're just going to go right to roughing. Now, if I put myself in a turning view, you can see I'm using a nice neutral tool. I want to machine straight down that way, but as you can see by the orientation of my tool, it's not good. It won't work. How do we change this? We go here to our WCS solutions and we choose the angle we want to work at. So for example, I can set myself to 0 and 45 degrees. As soon as I do that, you can see the tool display updates, and moreover, you can see the tool path. Perfect. Over here, I'm going to set the stock to leave. I want to leave 10 thousandths, and maybe my depth of cut, I want to set at 30 thousandths. Awesome. Next, I'll set my feeds and speeds. I want to work in feet per minute. So I'm going to come in here and say, you know what, I want 800 surface feet, maybe 20 thousandths per revolution. I'm going to set the maximum RPM to be maybe 3 grand in this case. That's it, I'm done. So I'm going to validate. TopSolid's going to calculate. It's going to go directly into simulation. I can zoom out and you can see I've turned down the face of this part. That's actually pretty easy. If you think about it, I'm using a complex machine and doing a very basic turning operation, but sometimes it's not so simple in some of the applications out there. Next, what I want to do is I want to continue turning. I want to turn from this face to here. So I'm going to select this face, hold Alt, select here, right click, roughing again. Now in this case I want to reuse some of these settings, so I'm going to drag and drop down to here to use the same angular solution. I'm going to drag and drop down to here to use the same general settings. I'm going to drag and drop to here to use the same feeds and speeds. About the only two things I want to change is my cut direction, and if I go into my settings, I want to stop my tool path before it hits my jaws here. One of the beauties of working in machine simulation like this, with all your fixturings present, is that you can see everything. It helps you make really good decisions. Now, some might ask, why isn't TopSolid avoiding that? That's a great question, and the reason TopSolid's not avoiding it is because I simply have that option turned off at the moment. This way I can show you some manual steps in the solution. So if I go to my stock to leave and limits, I'm going to turn off chuck jaw avoidance, and I'm going to go to my Z limitation. Now here, I can just type a value. I can say, you know what, -3. Let's see what that looks like. Maybe -3.5. Maybe a little bit more, -4. Perfect. I could have also switched to a point selection and snap to a point. You can do whatever you want. The only other thing I'm going to change is I've decided I don't want that 30,000 step to cut since I'm turning down the length. Maybe 100 thousandths works better. And I'll say go. Like that, TopSolid's now going to update the stock. Again, you're going to see that simulation do its thing. And we're done again. Again, what I'm trying to point out during these videos is just how quickly and easily you can get things machined within the TopSolid solution. Next, maybe what I want to do is drill down the center here. So I'm going to right click here, go to drilling, and choose hole machining. Now here we have a large diameter hole. Okay? And what I want to do is I'm going to use a flat drill that's 1.5 inches in diameter. Go ahead and select that. Next, what I want to do is I'm going to tell it to take this all the way through the stock. So I'm going to change my geometry type to be through stock. Perfect, just like that. Now, the only thing really next that I need to do is I need to choose what's spinning, what's not. So I can choose the tool is spinning or the part is spinning or both. In this case, I'm going to let the part be the one that's spinning. And I'll give it, again, speeds and feeds. You can see it's copied over from the last time that I've used this tool. And then here you can choose whether you want a pecking cycle, clearing cycle, whatever. The choice is yours. But at the end of the day, again, even that operation only took a few seconds. We're in, we're out, and we're done. Perfect. Now I'm going to go to my turning tab here next, and I'm going to go ahead and turn on turning visualization. And what that's going to do is that's going to let me see inside my part. I can set the angle however I want, but this way I can see the ID of the part a little bit better. Because now what I want to do is I want to machine from here, and I'm going to hold Alt to here, and I want to do some ID turning. So I'm going to go to roughing again. This time I'm going to switch tools because that tool is no good for me. I'm going to switch to this tool. Now when I switch to this tool, you can see this tool has a specific reach to it, right? And I want to machine along that direction. Now you can see right here that the tool can't possibly reach all the way through the stock here. So we need to set another limit. How do we do that? Let's go back to settings, and here we'll go to stock to leave limits. We'll say in Z again, and this time I'll go to a point. Now the way you can do this is I could just select on the model like that, but you probably want to go a little bit past that. So look how easy this is. I can say let's create an offset point from here relative to my Z axis in the opposite direction for 30 thousandths, for example. Perfect. Now I have a point that's going beyond my detail just a little bit. All the rest of my settings are exactly as I want them. If I hold this here, you can see I'm good. I shouldn't have a collision, but you know what? I want to be really sure. It'd be really cool if we could turn on the machining head at the same time and drag that around. Let's zoom up here and have a look. Well, cool. I don't have a lot of clearance, but I have enough to reach this part with my current configuration. This is, again, one of the cool factors of TopSolid. You can visualize everything extremely easily. All right, we're done there. Let's go ahead and say OK. We'll watch the simulation come in. Tool's going to come down, and I'll slow this thing way down so we see. And you're going to see if I zoom way up on this, we're going to get close, right? But no collision found. Fantastic. Rough, 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 and away we go. All right, now next I want to go ahead and create some finish turning. So I'm going to go ahead and finish turn from here to here again, and I'm going to use that same tool just to keep things simple for the demonstration. You can see it's going to come in, it's going to turn, it's going to be done. Again, nice and easy. After that, what I want to do is finish turn the outside. So I'm going to rotate this a little bit, select this face, and maybe I'm going to finish turn up to here. Okay? So let's go here and we'll go to finishing. Now in this case, I could of course use this tool. You can see it oriented it vertical, and technically maybe it would work, but that tool's sticking out a far way. So I'm going to tool change, go back to my neutral tool, and I'm going to go back and grab that 45-degree orientation. And then I'm going to go to my lead and lead out and just show you some other options you have. So for my lead out, for example, I want to step back a little bit. So I want to be -1 inch or -0.875. There's other ways to control this. Again, I'm just showing you that you have freedom in TopSolid to just tell it to do something and it listens. That's awesome. Now that we've got that done, we have one more turning operation to deal with, and that's this operation here. So what I'm going to do is select this face to this face, and I'm going to go to roughing. And in this case, I'm going to switch from general roughing to what we call groove style roughing. We'll look straight back at it again, and now let's go pick our groove tool. Now when I pick my groove tool, you'll see it pop up here, and you can see how the tool is oriented. Well, this won't work very well because we're going to run into things. So I need to come over to here and ask the software to just rotate 180 degrees. Perfect. Now we're good. Now I'm driving by the wrong point, so I'm going to say let's change my program point to be the outside point. Awesome. And from there you can choose any type of cycle you want. Here it's just doing a plunge type of a method. Maybe if you want, we could do this a bit more interesting. Let's go here and do a zigzag. Okay, and let's maybe say that it's 60 thousandths. And you can see here it's zigzagging back and forth, and then it's going to level out and machine our profile. Again, I'm hopping all over the place in a couple of different styles of machining just to show you how simple it can be to program even a complex machine such as this. Last step we have to do is finish that face, so let's go ahead and do that. I'm going to select here to that face. I'm going to go to finishing, and in this case I'm going to switch back to that groove tool again. Look straight at it, and I'm going to use the same orientation the tool is already on. Right, so I want the tool inverted, which is perfect. And now what I want to do is I'm going to tell this to finish from two sides. So this way I can plunge down this way with the tool, pick up, come over here, plunge over, pick up. Let's have a look at that. Again, simplicity is the key. If you can't process your parts quickly, software isn't worth using. So here you can see the simulation. Now it's going to pick up and it's going to go down that vertical face, blending everything together beautifully. Okay, that's it for turning. So in a few short minutes, I was able to do a majority of the turning on this first setup. Next, it's time to do some milling. And to make the milling a little bit easier to see, I'm going to go turn off that turning display. And let's start doing some milling. So I'm going to select this face here, right click, and go to End Milling. It's going to be nice and simple. You're going to see we stick it into the tool into the right orientation right off the bat. I'm going to say that I want to leave 10 thousandths on the floor, 10 thousandths on the wall, and no spring pass here. Maybe I want this to be, I don't know, 1/8 inch depth of cut even. Perfect. We can set our feeds and speeds. Let's go here. By the way, to the keen observer, you will notice that I didn't set my plane, did I? Check this out. Because TopSolid fully understands the kinematic capability of this machine, it is able to automatically find the right angular solution for you for all your 2.5 axis milling on 5 axis positioning. Pretty cool. So we found that orientation, we did the tool path, we roughed it out. What's next? Well, what's next is this. On this side of the part, it has a cousin. There's another pocket on this side. So check this out. That's the tool path we used over there. Wouldn't it be awesome if you could just hold the control key down and drag and drop the tool path over to here, and TopSolid would automatically find the new angular solution and create the tool path? We thought it'd be awesome too, and that's why we did it. In fact, all we're doing is harnessing the power of Windows here. Now I'm going to drag and drop to this face. Perfect. It's going to update there. Now, when we update here, notice it's creating all the tool path based on the real stock. We're cutting zero error here. Again, a fantastic feature of the TopSolid platform. Let's do one more. Let's drag and drop this one down to this face, and now that's roughed out. Even better. Last step I'm going to do in the world of multi-axis machining. Let's machine a 4-axis slot. Select it, right-click, and under 2D, we still go to End Milling. We don't go to a special command just because the pocket happens to be wrapped around a cylinder. Instead, we just have to tell TopSolid we need to use multi-axis tools. So I want to use 4-axis radial machining. I'm going to see it update here in a sec. You can even send a cycle. We support 4-axis radial cycles here, which is awesome. Now, in 4-axis radial mode like this, you do have to help TopSolid out a little bit. It doesn't know the start altitude. All the other ones it's able to figure out, but in 4-axis continuous, sometimes it gets a little confused. So if I go to my altitudes here, I can go to my starting altitude, switch to point, and check this out. All I need to do is select a point on the model, and it'll find the right altitude. The other thing I want to point out, notice it's plunging where there's no material automatically. I mean, that's just awesome. Let's say here we want to leave 10 thousandths on the wall. Again, 10 thousandths on the floor. Let's say everything else, we don't need a skim pass there. One pass is enough for roughing sake. And now let's watch. So now we're going to orient the tool. We're going to pick up, and we're plunging inside the part there where there's ear, and we're cutting in 4-axis continuous. Awesome. And think about that. I didn't have to recreate geometry. I didn't have to draw anything. I didn't have to unroll anything. All I did was process. That's the whole idea with the TopSolid platform. Last thing I'm going to show you in this video, because we're about 13 minutes in now, I'm going to do some milling on the front end here. I'm just going to pick one of these faces to machine. Okay? I'll pick right here, and I'm going to go to End Milling again. Boom. Check that out. It found every single pocket. I mean, every one. That's awesome. I'm going to, again, set my stock to leave. And by the way, I could have all of these defaulted, but if I had them all defaulted for the video, honestly, my demo would go so fast you wouldn't know what I did. Check it out. Boom. Now I've just roughed all those out. Now, something interesting is happening here. Okay? I don't know if you guys caught it or not, but I had a red value here in the simulation. Let me stop it, rewind it, and start it again. My y-axis is over traveled. Huh. Now we're back into the right zone. Okay? And as we get this around to the other side of the part, we're going to over travel x as well. I know this because that underline right there is telling me. And here it's telling me a couple of the axes are over traveling. I can go into here and I can look. I can say, what are the strokes of this? And x and y have over traveled. Well, think about it. That's just Awesome. How do we fix this? Well, we can get rid of one of these or solve one of these by going to polar coordinates. All I have to do is activate multi-axis. I'm going to initialize the angle to 0 and hit go. Now it's going to recalculate, and now we got rid of the x-axis over travel. We still have a y-axis over travel to solve, and I'll show you how to solve that too. But now you can see we're just using the c-axis to machine those pockets. Same simple command, and we were done. Awesome. How do we get rid of the y-axis over travel? Well, let's have a look. I'll bet you the y-axis travel is happening in what we call the link movement. You know, sometimes link movements can be challenging. Thankfully, TopSolid has the ability, or I should say, gives you the ability to tell it exactly what you want to do. So look, here we're moving to this plane. Okay, I'm going to turn off automatic because I'm going to solve something. It's this movement here that's over traveling y. I know that because that's underlined. So let's just get rid of it. Perfect. Now in this case, the tool moved out to a circular plane here, which is fine. And then it's going to rotate B and C. And then it's going to position back. And then. And you can tell it to do whatever you need it to do. For example, maybe here you don't want to use the plane. Fine. Let's go here and let's do a movement to coordinates. Watch. What I'm going to do is I want to approach in my part frame in the z value based on the ending point plus 5 inches. Just want to get it out there. Maybe even 8 inches. Why not? Cool. Then watch what happens. Then we're going to rotate up, and then we'll be coming down and over and away. But like that, we have now solved the over travel alarm. Let's recalculate, and we're done. No more over travels. Working with the software that really understands your machine, understands what it's mechanically capable of, and more, gives you the tools to be able to program that machine with efficiency is the only way to drive machines like this. Finally, the proof is always in the pudding, right? If the simulation is pretty, that's one thing. But if there's no G-code, there's no point. So the last step I'm going to show you, I'm going to come up to here and go to Generate ISO. In this case, I'm going to post for an Integrex J-series with a matrix control. I'm going to hit go. And like that, you now have all the G-code needed to do everything that we just did, or that we just programmed within TopSolid. Hope you enjoyed this video. Check back to the blog soon because, as I promised, there is going to be a full tutorial on how to do everything I just ripped through in this presentation. Thanks for watching.